All right, this is the second half, just finishing up the variance. There was a discrepancy in one of the numbers. I wanted to make sure that I did this correctly. So when we start finding the deviation scores and then squaring them, we put the values here in the x minus the m squared category column, and we'll do those calculations all the way down. So negative 3.63 squared, 13.18, we'll do that for each of our deviation values all the way to the bottom. The last one will be 12.37 squared is 153.02. Once we have all of those, we can sum them together. We want to add them all together. Add this column up to the end and the sum will be 411.80. That is our sums of squares, the sum of all of the squared deviations. The next thing that we're going to do is we're going to make it into a usable unit called the variance. You will be using the variance throughout the rest of the semester. The variance is the overall spread. To get that, we take our sums of squares and divide it by n, which, as we remember over here, n is the number of scores in the sample. So over here, the number of scores is 16. We have 16 of these in here, so we divide the sums of the squares by the number 16, and we get 25.74. That is our variance number. We don't report that in research. We actually use a derivative of that called the standard deviation, or the average amount at each score varies from the mean. To find that, we need the variance though, so we start with it. So we're starting with that variance, then we take that number and it is simply the square root. That is what our standard deviation is, the square root of the variance. So in this case, 25.74 square root 5.07. So now we can describe the spread of this distribution. It has a mean of 22.63, a variance of 25.74, but this is really where we will come down to it. We have a standard deviation of 5.07, which means from 22.63 on average, the scores go up mostly about 5 points above and 5 points below. And in our next chapter, we'll be talking about what that means when we have a variance and a standard deviation. We can look at the shape of the distribution.